Hello Earth, welcome to episode 32 of season 4 of Making Cell, a series of videos where I record myself designing and implementing a programming substrate called Cell. If you're just tuning in for the first time, I recommend you go check out github.com/autocoronel/cell. I'm pasting now the link in the description. Where were we yesterday? Yes, yesterday we were in a very interesting place. These are just a couple of observations I did earlier today, where we were basically going through how the expansion is done. Sorry, not the expansion, the recalculation. And I think we can attack this problem because that's the only thing we need to do right now, right? Yeah, this thing. Yeah. So how should it work? So I have this. So it's all passing just fine, right? Yes. So how could I change it? And I think it's also everything's committed. Yes, perfect. Annoying all that stuff. Perfect. Better. So this is all good. I really like this representation of what's going on at every step. I want to see when I am here. We're calling native, but where are we putting this one here? We're still not doing that, right? Because we have this. Well, this one still didn't have its thing. This call has no response. So when are we doing that right now? Well, we make the call to native, and then we re-enter. So there's something that is not a no, because look at how here suddenly we have this and this. But that won't happen at the same time, right? I guess it could happen at the same time. I think I could do it like this. Working the thing from yesterday. Until step 4 we are okay. And then we do this. Could be data space 11 at equal 11. Static. It will be on the path 11 at plus 110 of do. Actually, let's just copy this whole thing. So what I'm looking for is up do destination +1 message 10 up put result from step 1 and put it as the overall result. Wait. Yeah. Sorry, I did on the wrong one. I'm losing it. What's going on? No, it's fine that I do it in the 5. This is wrong. I'm completely lost. I'm really annoyed with myself. Sorry. Let's look at yesterday notes. Come on. I guess it wasn't a great day today. It's okay. This is part of it, right? It's all the same. Yeah. It's all the same. Yeah, so that's the difference. So by step 4 we have the same things, the add, and then the next one we have this thing here, and then we got this. Yeah, it was fine. Yeah, so basically 5 is 6 really, right? Yes. Yeah. Yeah, I think this is okay. It's like I cannot focus on this for some reason. I don't get it. So this is 6. So I come from having this one, now I have the result, and now I'm looking at the path here. Yeah, so that path is the same twice, right? Yeah, why do I have end here? It should be 10. No, actually the path here is 11 again. So let's do it again. Yes, the first path. Again, the first path. Now we got this one. Now we do this one. Now we do that one. Now we this one has all the results. So I do that one. Yeah, it's fine. This is wrong completely. I just changed the wrong one before. Nice, and that's it. That's the end. And do it like this. Yeah. Let's review the expansion in lines 218 to 289 of readme and think it through. See if it makes sense. So what are the dependencies? Let's just look at the paths that have calls. Holy fuck, this is an amazing song. Wow. No, what am I doing? It's only just 4, it's this one. Oh, it's really taking its time. Taking just call prefixes. Fuck yeah. It's interesting how this almost violates the notion of the paths being, the call prefixes being a data space, because this definitely wouldn't make this whole thing a hash, and it's fine. Because the expansion counts in the middle. Okay, logically correct, blah, blah, blah. Thanks for checking. Step, the int one is a sort of call signature. Name of the argument, number of steps. Server. Dependencies. Yeah, this one depends on. I did this last time, but I'm gonna do it again until I know it by heart. It will be 11 at int. Do it like this. Like this. Come on, come on, come on. I need to use the presentation. Well, that's not mine. The one that I had the luck to stumble upon. I need to use this for everything to think it through. Use the paradigm. So this one relies on what? Now see how I'm doing stupid shit here. This one depends on this one. The result of that step depends on add, right? Or add one. No, add. I'm not so sure about this. Let's think it through. 11, add, do. 11 colon do. X. 11 colon do. Where's the call? Yeah, the thing is, 1 is not a call, man. It is not a call. This was fine the way I was doing before. Why do I say that this is a call prefix? 11 colon do 1. Ah, yeah, because I have an add. Yeah, sorry, silly me. Yeah, it's correct. And this depends on two things, not one. It depends on add itself. And the message to add, right? But how can I know the message to add? Can I do something like what I did last time? Not last episode, but a bit before. Like I can do something like 11 add do 1 add, something like this. Add? No, because that's not a call. Yeah. I think the safe thing to do would be to say add. It depends on add, and it depends on 11 colon int. Because that's really it. But how do I know this? It's not so straightforward to figure it out. I would see this is the destination of the call, and then on what does the message depend? That's the question, right? Yes. I'm tempted to do a strip over the entire definition. I want another version. No. There's another one. This one. Yes. And then how do I say that 11 depends on this is a bit silly. I could just recalculate the whole function, sorry, the whole call, right? But that wouldn't be very efficient. I want to have granularity inside a function, a call sequence function. I don't want to throw it all away. I want to change. It has to go through. Should. I'm thinking 11 really depends on +1, but then it depends on I can just do this 11 colon possible changes. And also here I would have a circular dependency. If I say that 11 colon do depends on 11 and then 11 depends on 11 colon, because it kind of does, right? Because if I change 11 itself, there's an elegant shape here. I'm not seeing it. It's there, but I can. Because 11 colon really. 11 colon cannot change. 11 colon, yeah, I need to. No, 11 colon. 11 doesn't depend on 11 colon. It depends on what it calls. If there's a change to plus, excuse me for a minute. Yes, maybe we can do this one. If the change to +1, it should recompute. But its sequence will change depending on where 11 points itself. Can I still have granularity? This is a control. This is fine. Could I just say that 11 colon do 1 depends on 11? And 11 really depends on +1. Possible changes. put 11 plus 1 set a new message on 11. Change definition on plus 1. Definition of add. Yeah, that makes sense. Those are the only things that if this change in add, this would change. If this change, why is this not being reflected in 11? The problem is like if that dependency on (11). If add changes, how does that change float up? I'm really resisting batching the lookup of references. Perhaps there's no way around it, because in +1 the definition is muted. We don't look into it. We only look at it on expansion time. Read up on my dilemmas just below in the readme until line not that I should. Ah. What is complicating things is to have colon between at and equal. Otherwise, it would be a clean chain. There's too much going on with the sequence. No, Claude didn't get it either. Listen. Yeah. I'm thinking. Restart dependencies. Hey there. So, what is it going to be? When the crux of the problem is that the expansion is expansion a dependence or a dependency? It is both. I have to accept it. But how do we accept it without being circular? All right. This is a bit silly, but necessary. Well, it's not silly. I just I don't seem to be accepting the difficulty in this. If I don't eagerly expand dependencies, then expansion is then the depends on the expansion. Has to depend. Change in add would affect it. It doesn't. Add needs to be added to the list of dependencies of the call. We could do this at runtime, or rather at expansion time. Eleven depends on add and plus one. This is the real dependency graph. How would we build it? First time we see 11 at plus 1, 10. We create our first step. As the expansion when we hit the moment of the expansion where we see a call to add, we resolve the absolute path to be at add top level. In this case, native because there's no call defined, and then so we now have how do we know not to add the call to int, because it is a call to 11 int, since that's 11 is a prefix of fit of that path. No need. Now what if we had this? Then we really have to have this depth. Yeah. Sorry, my bad. I want to do something fun with cell. I'm not having fun right now. Maybe it's just a frame of mind that I'm bringing. But yeah. Yeah, this makes sense. Now, can I do this simply? You could say that 11 add plus 1 depends on value, and 11 depends on 11 add plus 1. Or you could just basically target this on this one, but then how would you know the absolute one? Yeah, it could work. What would be on this bus? Sorry, this bus. Almost. That should be. I forgot the call. What would it be? It really depends on put. No, sorry, it depends on this bus first. Depends on put. Depends on if. Depends on this one. N comes from there, so it doesn't depend on it. Yeah, you want the dynamic system, okay. Deal with it. Yeah, it depends on all that. Okay, I will do something to feel marginally better, which is this. Mod. I'm missing the logical ones. It's not a big deal. Allows okay. This could work. Wow, this is getting very heavy. What's the difficulty here? Why am I stuck? Besides the fact that I desperately want this to to function, so I can just do a little script or something. I want to write this down. The idea and even vision of a value being valid until it is removed is very, very strong. There's no staleness. The moment that something is stale, it is removed, and then the new results, like water flowing down, come up. I am struggling with two things. Figure out an algorithm that is self-similar and doesn't really budge when computing depths. Figure out if a sequence changes propagate properly. I think I almost have it. Okay, let's just do something else for a few minutes. Or not. Well, what I wanted to do was to I had this one before. Let's generate this basically is implementation of Leaf in and ourselves why this is worthwhile. Let's look at lith, or part of it, if it was done in cell rather than in JavaScript. Now I need to put, is it colon text? I think so, right? Yeah, because yes, definitely. Or not. No, it's just text. Yeah. You have the iteration there. Yeah, it's just powerful. Text is the, sorry, there is the argument. And I'm operating on this text that's here. It's fantastic. Just taking the outermost text and changing it there is fantastic. Here I need to clarify that I'm doing paths, right? Yep. Don't I need a dot there? No, because I have colon. Of course. Keep on forgetting. Yeah, maybe I could use a switch statement here. It's just fantastic. The commas, I had forgotten. Yeah. Yeah, if I can do this, then this will work. The language will work. I'm gonna stop here. Bit of a bummer session, but I still think we made progress. Thank you for watching.